We might have been looking at the Tesla Semi the wrong way. It's not a burden. It could actually become Tesla's flagship product in the years ahead. Elon Musk has repeatedly called the Tesla Semi a money machine, and for good reason. It's currently the electric truck with the lowest energy consumption per mile, and you'd be hard-pressed to find another heavy-duty truck that runs for just about 15 cents per mile. That's why Musk is so confident that in the future, freight companies that refuse to switch to electric trucks like the Semi could actually end up losing money. For years, this idea was met with heavy skepticism in the trucking industry. After all, diesel-powered trucks have dominated logistics for decades, and many believed electric trucks simply couldn't match them in cost, durability, or long-haul performance. But now, real-world data is starting to suggest that Tesla's CEO may not have been exaggerating at all. So the real question is, just how efficient and cost-effective is the Tesla Semi? The strongest evidence comes from a real-world pilot program run by the logistics company Moan Transport in Texas. And this wasn't a controlled lab test or a perfect demonstration route. Instead, the Tesla Semi was used exactly like any commercial truck, hauling real freight, driving long-distance routes, and operating continuously inside a real logistics network. Over the course of the trial, the truck covered more than 4,700 miles. And what's even more impressive is that the results actually exceeded Tesla's own expectations. So what happened? According to data released by Moan Transport, the Tesla Semi achieved an average energy consumption of just 1.64 kilowatt-hours per mile. That's extremely impressive, considering Tesla originally projected around 1.7 kilowatt-hours per mile. In other words, in real-world conditions, the truck performed better than what the company itself promised. But the real shock for the trucking industry isn't just efficiency, it's the operating cost that comes with it. In Texas, the average commercial electricity price is about 9.12 cents per kilowatt hour. When you multiply that by 1.64 kilowatt hours per mile, the Tesla Semi comes out to roughly 15 cents per mile in energy cost. That might not sound dramatic at first, but in trucking, where vehicles run hundreds of thousands of miles per year, even a difference of a few cents per mile completely transforms profitability. To understand how big this is, we need to compare it with traditional diesel trucks, which still dominate global freight today. A typical Class 8 diesel truck gets around 6 to 7 miles per gallon. Using an average of 6.5 mpg and a diesel price of about $3.11 per gallon in the Gulf Coast region, the fuel cost comes out to roughly 48 cents per mile. Now put that side by side. Tesla Semi, about 15 cents per mile. Diesel truck, about 48 cents per mile. The difference is massive. It means the Tesla Semi cuts energy costs by nearly 70% compared to diesel trucks. And in logistics, that gap is enormous. A long-haul truck can easily travel around 100,000 miles per year. At 48 cents per mile, that's about $48,000 per year just in fuel costs. But with the Tesla Semi at 15 cents per mile, the same distance costs only around $15,000 per year. That's a savings of roughly $33,000 per truck every single year. Now scale that across a fleet of 100 trucks, and the savings jump to over $3 million annually just from energy alone. Over a typical 10-year lifespan, that translates into tens of millions in potential savings. And that's exactly why Elon Musk calls the Tesla Semi a money machine, not just because of its technology, but because it introduces a completely new economic model for trucking. And the advantages don't stop at fuel savings. The Tesla Semi also has the potential to dramatically reduce maintenance costs. Traditional diesel trucks are built with thousands of complex mechanical parts, multi-gear transmissions, exhaust after-treatment systems, fuel pumps, turbochargers, and many other components that all require constant maintenance and can fail over time. By contrast, an electric drivetrain is far simpler, with significantly fewer moving parts. That means less wear and tear, a lower risk of mechanical failure, and ultimately much lower maintenance costs over time. There's also another major advantage: energy price stability.
Diesel prices on the global market can fluctuate heavily due to geopolitical tensions. For example, conflicts involving the US and Iran, and you already know how unstable those situations can become. We won't go too deep into that here, but the key point is simple. Fuel prices are likely to become even more volatile in the future.
Confirmed.
Electricity, on the other hand, is generally far more stable, especially when companies lock in long-term power purchase agreements. That allows trucking companies to forecast operating costs with far greater accuracy and plan their finances with confidence. So far, the operating cost advantage is clearly the strongest proof that the Tesla Semi could truly be a money machine. But that raises another important question. What is it actually like for the driver inside the truck? Is the experience really as good as Tesla claims? Because in trucking, efficiency alone isn't enough. Driver experience matters just as much. A truck might be extremely cost-effective, but if it's uncomfortable, difficult to operate, or exhausting over long hours, it will struggle to be adopted at scale by logistics companies. Earlier versions of the Tesla Semi still had a few limitations. That's why in the newer production version, Tesla introduced a series of important upgrades inside the cabin, focused on improving the long-haul driving experience. In the earlier prototype, the Tesla Semi already stood out by replacing the traditional instrument cluster with 15-inch displays. But in the updated version, Tesla has upgraded these screens to 16 inches, giving drivers more space and better visibility. These two displays act as the central control hub of the truck. Everything from speed, energy usage, navigation, trip data, and safety alerts is shown in real time through a fully digital interface. This is a major shift compared to traditional diesel trucks, where dashboards still rely heavily on analog gauges and limited information screens. Inside the Tesla Semi, the entire driving experience becomes almost fully digital, similar to what Tesla has already implemented in its passenger vehicles for years. Not only does this make it easier for drivers to monitor the truck's condition, but it also allows Tesla to push over-the-air software updates, improving features and refining the interface over time.
In other words, the Semi starts to feel less like a traditional freight truck and more like a modern piece of technology on wheels. Alongside the upgraded display system, Tesla has also significantly improved visibility by adding a network of up to 10 cameras around the vehicle. In heavy-duty trucking, visibility is one of the biggest challenges. These massive vehicles, often stretching dozens of meters, naturally create large blind spots, especially in tight environments like ports, warehouses, and busy logistics hubs. The Tesla Semi's camera system creates an almost 360-degree view around the truck. All camera feeds are displayed directly on the two large cabin screens, allowing the driver to monitor the surroundings at a glance. Compared to traditional side mirrors, this system offers a much wider field of view, reduces blind spots, and integrates seamlessly with advanced safety features. More importantly, it also lays the foundation for advanced driver assistance systems and potentially even full autonomy in the future, something Elon Musk has repeatedly hinted at. In Tesla's long-term vision, cameras act as the eyes of the vehicle, helping it understand its surroundings and react intelligently to real-world conditions. Another key addition inside the cabin is a driver attention monitoring camera. This type of system is becoming increasingly common in modern vehicles equipped with advanced driver assistance technology. It tracks the driver's eye movement and attention level, ensuring they remain focused while assistance features are active. If the system detects distraction or prolonged inattention, it immediately triggers a warning. This helps improve safety while still allowing drivers to benefit from advanced driving support systems. It also reflects Tesla's broader approach, where automation and human oversight work together to enhance overall road safety. In long-haul trucking, where drivers can spend hours behind the wheel, this kind of monitoring can significantly reduce accident risk. Beyond the high-tech upgrades, Tesla has also focused on small but highly practical improvements for everyday use. One example is the redesigned side window of the cabin. In earlier prototypes, the design was extremely aerodynamic,
but some drivers felt it wasn't ideal for real-world interactions.
Transportation
In
is
actual
here.
trucking operations,
Powerful,
drivers often need to communicate directly with workers at toll booths, warehouse gates, and loading docks. The updated window design allows drivers to comfortably extend their arm outside when needed, improving practicality while maintaining the truck's modern aerodynamic profile. Tesla has also repositioned the cup holders inside the cabin for better accessibility and convenience. It might sound like a small change, but for drivers who spend long hours behind the wheel, even minor ergonomic improvements can make a huge difference. In the previous version, the cup holders were positioned quite low, forcing drivers to lean down every time they wanted a drink. In the updated version, Tesla has moved them higher and closer to the main control area, allowing drivers to grab a drink easily without taking their eyes off the road for too long. The storage space inside the cabin has also been improved. The Tesla Semi already has a unique layout, with the driver's seat positioned in the center and two walkways on either side, creating a noticeably more open and spacious feel compared to traditional trucks. In the updated design, Tesla has made better use of that space by adding larger storage compartments near the cup holder area. This gives drivers extra room for essentials like phones, notebooks, tablets, and other tools they rely on during daily operations. Finally, Tesla has also added integrated wireless phone charging inside the cabin. In today's trucking environment, smartphones are no longer just communication devices. They are essential work tools for dispatching, navigation, route tracking, and delivery management. With built-in wireless charging, drivers no longer have to deal with messy cables, and their devices stay powered throughout the entire journey. Now, while all of these cabin upgrades improve the driver experience, there's another big debate surrounding the Tesla Semi. Many critics argue that Tesla will never truly compete with major truck manufacturers because the Semi supposedly cannot operate in Europe, a massive and highly profitable trucking market. To be fair, for many years, Tesla has mainly focused on the North American market, where highways are long, freight infrastructure is more open, and regulations are relatively flexible. And even today, in the US, Tesla is still behind established competitors in terms of adoption. The main reason is simple: production volume. So far, fewer than 1,000 Tesla Semis have been built. But recently, we got our first real look at Tesla's mass production line for the Semi, and it appears both advanced and scaled for much higher output. Tesla is now preparing to ramp up Semi production, and Elon Musk has also confirmed that the company is exploring the possibility of bringing the Tesla Semi to Europe and potentially even manufacturing it in Germany. That single idea immediately challenges the long-standing belief that the Semi is only meant for North America. According to Musk's timeline, the Tesla Semi could enter the European market as early as next year if everything goes according to plan. As expected, that announcement sparked major discussion across the global trucking industry. Europe is one of the most competitive trucking markets in the world, dominated for decades by established giants like Volvo Trucks, Daimler Truck, Mercedes-Benz, and DAF Trucks. These companies already have strong manufacturing networks, distribution systems, and after-sales support across the region. In recent years, many of these manufacturers have also begun launching their own electric trucks as part of the shift towards zero-emission transport. That means if Tesla truly enters the European market with the Semi, it will face far tougher competition than it does in the United States. However, producing the Tesla Semi in Berlin actually makes strategic sense. Instead of shipping trucks from the US to Europe, manufacturing them at Tesla's Gigafactory Berlin-Brandenburg would reduce logistics costs, avoid import tariffs, and most importantly, allow Tesla to adapt the Semi to European roads and regulations. Because in reality, trucking conditions in Europe are very different from those in the US. In the US, heavy-duty trucks typically use a long nose design, where the engine sits in front of the cabin. This improves serviceability and allows for larger, more comfortable cabins. Additionally, US regulations mainly restrict trailer length, not tractor length. giving manufacturers more flexibility in vehicle design. In contrast, the European Union enforces much stricter total length regulations for the entire truck and trailer combination. As a result, most European trucks use a cab-over design, where the cabin sits directly above the front axle. This helps maximize cargo space within legal length limits. This fundamental difference is exactly why the Tesla Semi's long nose design could face challenges in Europe without significant modifications. Beyond length regulations, road conditions also matter. European roads are often narrower and filled with tight roundabouts, unlike the wide, straight highways commonly found in the United States. From a technical standpoint, the Tesla Semi currently has a wheelbase of roughly 200 to 230 inches, depending on configuration. While this works well in the US, it could create difficulties in tight European urban environments. Because of that, if Tesla builds the Semi in Berlin, it may need to redesign the chassis, possibly reducing the wheelbase to around 150 inches. And that is not a simple task. The Semi's large battery pack already occupies significant space under the chassis, so shrinking the structure while maintaining range and performance would require major engineering changes. Another key challenge often highlighted by industry experts is the absence of a sleeper cabin. The current Tesla Semi is primarily designed as a day cab, intended for daytime driving without a dedicated sleeping compartment. However, in Europe, driver regulations are much stricter. Truck drivers are typically limited to about 9 hours of driving per day, followed by at least 11 hours of mandatory rest. This makes sleeper cabs almost essential for long-haul European operations. So if Tesla wants to compete with companies like Volvo Trucks or Mercedes-Benz in that market, it may need to introduce a dedicated sleeper version of the Semi. With a total height of around 13 feet, integrating a compact sleeping system behind the cabin is technically possible. Some experts even suggest a fold-out smart bed system, turning the cabin into a compact, mobile living space for drivers. However, bringing the Tesla Semi to production in Berlin would also come with major challenges. The first is manufacturing infrastructure. Although Tesla unveiled the Semi back in 2017, large-scale production in the US is still ramping up. Establishing a full production line in Europe would take significant time and investment. The second challenge is battery supply. The Semi uses a battery pack far larger than a typical passenger EV. Scaling production in Europe remains difficult due to high energy costs and strict environmental regulations. If batteries are imported from outside Europe, shipping costs and tariffs could significantly increase the final price. And finally, one of the biggest challenges is charging infrastructure. The Semi relies on Tesla megachargers capable of delivering over 1 megawatt